Now that we have our product and quotient rules, let's take a look at some more complicated formulas involving the trig functions. We've seen already how to calculate derivatives of the sine and cosine values, sine and cosine functions, excuse me. So let's put that into practice here and differentiate y equals x squared sine x. Well, the product rule tells me that if I can write this as the product of two different functions, then dy dx is going to be one of those functions times the derivative of the other, plus the derivatives going the other way. Let's be explicit. Dy dx is x squared times the operator d on dx applied to sine of x. And then I have to add on sine of x times differential operator d on dx applied to x squared. Both of those are derivatives we can calculate separately. So I get the derivative of this function is equal to x squared times the cosine of x plus 2x sine of x. So I've previously said how the derivative of the cosine function is equal to minus the sine. And knowing the derivatives of both of these functions, together with the quotient rule, will let us calculate derivatives of all of the rest of the trig functions. So in my mind, the two most basic trig functions are sine and cosine. All of the rest of the trig functions are fractions involving those two functions. For example, if I wanted to calculate what is the derivative of the tangent function, why, that's the derivative of the sine of x divided by the cosine of x, and I can calculate that using the quotient rule. Let's do it. The quotient rule says, if I want the derivative of functions high divided by ho, then my formula is ho d high minus high d ho, square the bottom, and away I go. Here, my high function is sine of x. My ho function is cosine of x. So substituting those into my formula, I've got cosine of x, derivative of the sine, minus sine of x, derivative of the cosine, all divided by the cosine squared. Okay, well, I know the derivative of the sine function is equal to cosine. I know the derivative of the cosine function is equal to minus the sine function. Put those together and my numerator is going to be cosine squared x plus sine squared x. Oh, I know that one. That's just one. So my derivative of the tangent function is going to be 1 divided by the cosine squared of x. Now, since secant of x is 1 divided by a cosine function, then 1 divided by cosine squared of x has to be secant squared of x. This gives us our derivative for the tangent function. The derivative of the tangent function is secant squared of x. Here it is as a formula. Now, that's 3 trig functions down, sine, cosine, and tangent. 3 to go. Cosecant, cotangent, and secant itself. So let's take a look at those. If I take the derivative of the cosecant of x function, I'm going to get minus the cosecant of x times the cotangent of x. If I take the derivative of the secant of x function, then I get the secant of x times the tangent of x. And if I take the derivative of the cotangent function, I get minus the cosecant squared of x. So these 6 formulas are all the derivatives of all the trigonometric functions, at least the elementary ones.